So wherever, all of you can see the screen, right? So wherever these type of threads are there, what you are seeing on the screen, these thread, right, or rod, what you can say, the wire or rod, what you are seeing, these things wherever if it is being used, it is used only to measure the effective diameter of the screw thread. Effective diameter means pitch diameter of the screw thread. So pitch diameter is in between the major and minor diameter, which come in contact with the pitch line. See here also you can able to see on the screen here, these are the hooks through which these rods or wire will be hung. That's what is called floating carriage micrometer or bench micrometer. You can see in this screen also, these hooks what you are seeing, through that the wires will be hung using this instrument. The wires or rods will be hung, so which will come in contact with the screw threads. Right? The bench micrometer. In the last class, what we are discussing, right? So it is having the fiducial indicator. In the last class, I told, right? Fiducial indicator. What is the application of the fiducial indicator? It is used to make sure that the pressure which is applied on the screw thread will be same. It will not be varied from person to person. That is what fiducial indicator. You can see this pink color image here. This is the fiducial indicator. This is the anvil of this. And here one more anvil is the micrometer head. So through this you can able to get the reading. Through this fiducial indicator you can make sure that the pressure applied on the component is same. It will not be varied from person to person if you are using this floating carriage micrometer. If you are using this handheld micrometer, what you are seeing on the screen here, the chances of variation will be there for the application of the pressure, because you have to rotate this thimble to apply the pressure through the anvil onto the screw thread. One person may feel that it is tight, one person may feel that it is loose. So in order to overcome that, the more accurate or precise one is bench micrometer or floating carriage micrometer using the fiducial indicator, what you are seeing here, right? The external threads will be measured. So what we discussed in the last class is this major diameter. For external thread, major diameter is measured from crest to crest. So this point is crest, this point is crest. So for that, these are the measuring angles. This will come in contact with the crest to crest because you are measuring the major diameter of external threads. Right? See, first standard cylinder will be kept like you are seeing on the screen. This, then R1 reading will be taken. Then the standard cylinder will be removed. Then again they will place the screw thread, the actual workpiece. Then the major diameter will be measured. So major diameter for external thread means crest to crest. You can see here again. I put that same image again, right? From the crest to crest, major diameter. Again R2 will be taken. So using this formula, you can able to calculate the diameter, major diameter of the external screw thread. So in carriage micrometer, right? So here in this case it is showing like this drum, but in that case the video it was having the this type of digital micrometer. Right? If they are using the wires, is effective diameter. If they are not using the wires, it will be the major diameter what they are going to define. If they are using V, see here major diameter. They are not using any wire in this case. Measurement of major diameter. They are not using any wires, whether single wire, two wire, or three wire, right? It's just the major diameter from this point to this point. In the minor diameter, in the last class, what we discuss is to get the casting, and that casting they're going to measure it again the same way to measure the minor diameter of internal threads. Right? It is from this point to this point. Right? Internal threads. And again, in the last class, we discussed about this measurement of minor diameter, both for external threads as well as for internal threads. So measurement of minor diameter means you can see minor diameter here from root to root if it is external thread. If it is internal thread, minor diameter means from crest to crest. It's also called hole diameter. So these things we discussed in the last class itself, right? And see here, if they are using these type of, all of you can see the screen, right? So here, if you see the V prisms, if they are using these V prisms, then it is indication that they are actually measuring the minor diameter of the external threads. See now in this image, how these prisms will go to set like this, right? This anvil, fiducial indicator, and one more you're going to set here because it has to come in contact with the the crest because it is internal thread, right? Like this V prism. Then they are going to do the measurement in the similar way. So these three readings, S value, R1, R2, and for this they're going to substitute it. S plus or minus. They're not going to take always plus or minus. If they're going to take plus whenever the component is bigger than the standard cylinder. When the component, this screw thread is smaller than the standard cylinder, they're considered as minus in the formula, right? So this is the measurement of the minor diameter, which we discussed in the last class. And again, for internal threads, this is with respect to external threads. What you are seeing, external threads, right? Here, in minor diameter for external threads. Now, minor diameter for internal threads. So this is internal thread. An example of a nut, minor diameter, the red color line from this point to this point. Like I told in the last class, two methods will be used for it: taper parallels as well as the rollers. So this is the one method of measuring the internal diameter, taper parallels like this, and this is used only when the size or diameter of this particular internal thread or hole or the diameter is less than 200 millimeter. You can see here, right? And if it is more than 200 millimeter, they will use the standard rollers. See, roller means it is the wire only, right? This is the like the front view of it. It is the wire or rod, right? This, you have to assume that the rod will be placed here like this, right? This will come in contact only with this, right? Crest of the internal thread. Minor diameter means it is crest for the internal thread. The rod, you have to assume here, like this red color line is there, no? The rod or the wire will be here like this. And here also one wire will be there. In between these two wires, that wire is representing like these rollers. In between that, they will put the slip gauge to get the this minor diameter of the internal thread. That is the crest to crest internal thread, because it is internal thread. That's why here I am representing as crest from this point to this point using slip gauge as well as two rollers. Rollers in the sense these are the two wires, diameter of the two wires, right? That formula is this length of the slip gauge, right? This slip gauge, what you're seeing, that length plus here one wire is there, the diameter of one wire and diameter of another wire. So two wires, two times the diameters. You can see this image, right? In the last class I shown this again. Slip gauge. This is the wire, one wire, one wire. The diameter of this, the diameter of this. So major diameter, right? In the last class again I shown about this. I discussed about this flank angle. This based on the profile projector, optical projections. Using this protractor, you're going to measure the thread angle or flank angle. So till this, I think we are discussing the last class, right? Measurement of effective diameter. Effective diameter means it is the pitch diameter, right? Another name of effective diameter is pitch diameter. We can observe in this image, major diameter is this, minor diameter is this one, In between that, there will be pitch diameter. So always the pitch diameter is smaller than the major diameter. In that video also, you might have seen that one. Below the formula, they have mentioned pitch diameter is always smaller than the major diameter. It will be measured with respect to the pitch line. You can observe here on the screen this figure, right? And this effective diameter or pitch diameter, it can be measured by using two methods, two wire and three wire methods. That wire is that person what he is using in that video, right? It is a rod or the wire. Those wires, if you want to use it for the measurement, it has to be called as the best size wire. Should be best size wire. The wire, what you are seeing here, if you place that wire, this is the image. If you place that wire, best size wire, it has to make the contact with the flank like this, right? And there is a condition here. You can read the condition here at the bottom. The diameter of the wires, this wire, if you place on the screw thread here, those wires, if you keep it, the diameter of the wires used should be such that they contact the flank. Flank means this, right? These things you can observe here also, flank. You can contact the flank at a distance from the pitch line. So this is the pitch line. From the pitch line, not exceeding 1/12 of the length of the straight flank. That is the condition. If that condition satisfies, then it is considered as the best wire size. If it does not make a contact with the pitch line, if you take a bigger diameter wire, if it does not come in contact with the pitch line, then it is not a best wire. And suppose if you take the small wire and it will go to sit here at the bottom, right? You can see the cursor. If you see that here, if you become set at the bottom side, then it will become the smaller one. So not the bigger one, not the smaller one. You have to select the best size, right? Best wire size. See here, pitch diameter means in between major and the minor diameter. See here, this is the option of or the way in which you can able to measure using the handheld micrometer also. This also I was shown in the last. Right. So this is the way in which you can able to do the measurement of by using handheld micrometer also. Right. This is the example of three wire method. Right. Three wires. This is the one wire. These are the two wires. Always the selection of the wire, it should be the same size. Only the numbers is more here, right? 0.725, 0.725. This is considered as the best size. There are a lot of various threads various wires will be there or rods will be there. Among those, they are going to select only the best one, which will set or which will going to have made this condition, right? This condition, diameter of the wire should such that they contact the flank at a distance from the pitch line, not exceeding 1/12 of the length of the straight flank. That is the selection of this. They're going to place it and they can measure even on the this also handheld micrometer also, right? So now we are going to discuss about the two and three wire methods. See here, the effective diameter of screw thread may be ascertained by placing two wires or rods of identical diameter. Identical diameter means same diameter between the flank of the thread. You can observe here, between the flank of the thread, it is being kept and measure the distance over the outside of these wires. This is just an example of how to do the measurement. So we will discuss one by one. So now measurement of effective diameter or what we call as pitch diameter by two wire method. as the number specifies here, only 2 wires will be used or 2 rods will be used. Here what you are seeing is 3 wires. See here, this is 1 wire. Here there are 2 wires are there, right? Total 3 wire method. This is example of 3 wire method. But here what I am showing is it is 2 wire method. Only 2 wires will be used, right? So this is anvil. What you are seeing, anvil means anvil from the one side of the fiducial indicator, one side will be having the micrometer, right? If you are having the bench micrometer, if it is like this, you can see the image here. If it is a normal micrometer, these are the 2 anvils, right? In between these 2 anvil, you can observe here there is 1 wire, there is one more wire here, 2 wires. It will be mounted in opposite direction to this thread, to the given workpiece or the thread, right? This is the placement of the angles of this micrometer. Assume you are using now this micrometer, handheld micrometer. This is the angle which come in contact here. This is the one which will come in contact with this. Right? See, there are so many denotions. It is represented in this figure. See, E, it has been shown here. E represent, all of you know, it is effective diameter, right? Because it is measurement of effective diameter, or you can call it as pitch diameter. So always the pitch diameter is in between major and minor diameter. Again here one more denotation is the T, right? This T represent, you can see here, dimension under wires. So this is the wire, this is the wire. See the line for the T from this point to this point, it is represented as T, which is measured by m minus 2 times the diameter. See here, m means this position, m. So m is over the wire, dimension over the wires. T means under the wire. You can see the screen in the image. T is under the wire. M means over the wire. You can observe, right? Here, dimension over the wires. So m minus 2 times the D. D means diameter of each wire. This is the wire which is using, right? This is the best size wire which has been selected for measuring the effective diameter. And the diameter will be represented on the wire itself. The diameter is mentioned like this on the wire itself. That is the small d, what is talking about. Diameter of each wire. Then P, it is the pitch of the thread, right? See, effective diameter E, can be calculated by this formula. E is equal to T plus C. In some books or some videos, in that video also, you might have observed that it has been represented as E is equal to T plus P. I hope you noticed that in that formula what he was showing in that video, E is equal to T plus P. But here, to avoid the confusion, I will explain it later in the next slide. They are considered as C only. E is equal to T plus C. So finally, this is the equation for which you can able to substitute to get the effective diameter, or you can call it as pitch diameter of the given screw thread. That C is what it is represented as a constant value. It actually depends on diameter of the wires, the wire which has been selected. It depends on the pitch and angle of the screw thread. If it is V thread, then the angle will be 60 degree. If it is a Whitworth thread, the thread angle will be 55 degree, right? Depending on which type of angle of the screw thread is, what is the pitch of that, and what is the diameter, the C value will going to be depends. This is the formula, E is equal to T plus C. The same image I will take it in the next slide, so that you can able to understand it better. See here the process or procedure to measure the effective diameter by 2-wire method. See here, like I told, the effective diameter cannot be measured directly. Effective diameter means pitch diameter. It is in between major and minor diameter. It cannot be measured directly, but can be calculated from measurements made. It can be done by you having the measurements, by taking the readings. If you can ever substitute into the formula, you can get the reading. There is the meaning. See, in the second point, in this method, wires of suitable size are placed. Here you can see the image. These are the wires, or you can call it as a rod, best size. Suitable size means best size are placed between the standard and the micrometer anvils. Right? This is the standard roller. In that video also, the person shown that standard value of that cylinder, right? Then they're going to take the reading R1. Then they're going to have this replace the standard cylinder by screw thread. The second one, you can see the image, second one, right? The standard is replaced by screw thread to be measured, and the new reading is taken. It is considered to be as R2, right? And the screw thread is mounted between the centers, and wires are placed in the grooves, and reading M is taken. See, from the above reading, this is the E value. So I hope all of you understood, right? You go through that image. So from the above reading, effective diameter E is calculated. So E is equal to T plus C. Hey, mute yourself. Hey, if necessary, then only you unmute yourself, right? So this is the way in which the two-wire method will be using the two-wire method. The effective diameter will be calculated. E is equal to T plus C. One reading by using the standard cylinder, another with respect to the screw thread, the workpiece. You can observe in this image also the handheld micrometer. This is the given screw, and these are the screw threads, the standard wires which will be used to do the measurement. See now, like I said in the last class, to calculate it, because it is not directly obtained, right? You need to be doing the calculations to measure the effective diameter by using two-wire method. See, all of you see this screen here. This is the using the two-wire. You can see this image in the left side. This is the given screw thread. For the given screw thread, two wires will be there. Here one wire, here one wire. So it represents that it is two-wire method. Two wires have been used, and this is the micrometer anvils, which will press the wires into the this threads, right? See, M is here, E is here. This enlarged view, it is shown in the right side here with the some denotions for this, right? I will take this image again in the next slide to explain to do how to get the equation. It is like the small equation which is derived from this figure, right? It is important. Two-wire method, three-wire method. Most of the time in the VTU question paper, if we observe it, they keep on going to ask for this. Explain about the two-wire method of measuring the effective diameter, or three-wire method of measuring the effective diameter or pitch diameter. See, this is the image. All of you can see the screen, right? This image, the same thing I have taken, right? Because it is for the reference. The same image here, what you're seeing, I'm taken over here, right? See now here, to measure to get the equation, see here, you can read the sentence. See here, T is the dimension under the wires. T is the dimension under the wires, which is represented by m minus 2 times the diameter, like I shown in the previous one. Here, T means dimension under wires, m minus 2 times the diameter. M means distance over the wires. The same here it is been represented, where T is dimension under wires, which is m minus 2 times the d. You can observe here in this image T value, it is being shown under the wire. These double arrow mark what you are observing on the screen, that means it is the continuation. Right? If you continue over this side, it will be continuous from this bottom of this wire to this wire. The distance is t, which is m minus 2 times the d. So where d is the diameter of the wire and m is dimension over the wires. See here, c is a constant value, like represented, right, which depends on diameter of wires, pitch, as well as angle of the screw thread. Now, how to obtain the value of c? Now we will go to see, right? The value of c, because E is equal to T plus C is the equation, that C value, constant value, how to obtain? Here we have to consider the triangle OAB. You can see the screen in this side, OAB. I hope all of you can see the screen, right? OAB. That triangle here I have considered. You can see this red color triangle here. I have taken it OAB, right? You have to assume that this triangle I have taken over this side. The angle subtended for this, here it has been mentioned. You can see the cursor, theta by 2, right? That theta by 2 here I have taken the triangle, right? Right angle triangle. So this side is opposite, hypotenuse, adjacent. All of you know that one, right? See now this triangle, in the triangle OAB. Now with respect to the cosecant, you can see this here. For your reference, I have entered that formula also. Cosecant theta, all of you know that cosecant theta is 1 by sine theta. All of you can see, right, here on the screen. So cosecant theta is equal to 1 by sine theta. Don't get confused. I'm explaining slowly only, right? Cosecant theta is 1 by sine theta. Whereas sine theta means opposite by hypotenuse. All of you know, right? Sine theta means, you can see here, sine theta is opposite by hypotenuse. If you substitute here, so cosecant theta finally will become hypotenuse by opposite. See, hypotenuse by opposite. In this triangle OAB, hypotenuse means how much? OA. Opposite means OB. OA by OB. So here I have written as OA by OB. Hypotenuse by opposite. OA by OB. OA by OB is equal to cosecant theta. So OA by OB, cosecant theta. Instead of theta, you can represent as theta by 2. Because here theta is theta by 2. Right? All of you can understand, right? So OA by OB is equal to cosecant theta by 2. So if you keep the OA this side, so OB into cosecant theta by 2. It is simple, right? No confusion. OA by OB is equal to cosecant theta by 2. You're going to get. So OA, if you keep on the LHS left hand side, so right hand side will become OB into cosecant theta by 2. Now again OB, if you see here OB, this value OB on this main image, OB can write as d by 2, because this is diameter of the wire, small d. You can see here it is being represented on the cursor, right? D, small diameter, d by 2, that is represented here. OB means d by 2, small d by 2. Small d represent diameter of this wire, best wire, right? Best size wire, diameter by 2. into cosecant theta by 2. Again, this AG is equal to OA minus OG. This AG, you can see here, from this point, this is A, this is G. This AG, you can write in the terms of OG. This distance can be written in the form of AG can be written in the form of OA minus OG. From OA, if you subtract OG, you're going to get AG only, right? AG is equal to OA minus OG. That OA is what you got in the earlier one, right? OA is equal to D by 2 cosecant theta by 2. That is substituted here. OG main image also, OB as well as OG, it is D by 2 only diameter, because this is the diameter of the wire, D by 2, right? OB, OG, it is diameter, small diameter by 2, D by 2. And that if you substitute into this, AG is equal to OA minus OG, you're going to get this D by 2 as a common. So cosecant theta by 2 minus 1. Now one more triangle we have to consider from this main image, AFD. See that where it is AFD? Here A is there, F is here, D is here. Right? Assume this is the one more triangle you are considering, AFD. Right? Again, the subtended angle is theta by 2 for this. Now here, cot theta will going to be considered. So cot theta means 1 by tan theta. For a reference, I written here so that you can able to understand it. Cot theta means 1 by tan theta, trigonometric function. Cot theta is equal to 1 by tan theta, but tan theta is opposite by adjacent. So opposite by adjacent. So finally cot theta will become adjacent by opposite, right? So adjacent by opposite. Adjacent for this is which one? For this triangle AFD, this one. AF will be the adjacent, opposite will be D by DF. So from that you're going to get this equation. AF is equal to DF cot theta by 2. Why theta by 2? Because the value of theta here it is theta by 2. Similarly, what here I explained now. Similarly for this cot. So assuming the wire touches the flank exactly at the effective diameter, because it is the best size wire. So AF, this equation now, AF is equal to P by 4. For the DF value, here it is represented as P by 4. See where it is DF in the main image here. DF is from this point to this point. See, pitch means you can observe here P from the crest, the center of the crest of one thread to the center of crest of the adjacent thread. This is pitch, one pitch. In that, what will be the value of DF? Whether it is P by 2, P by 4 or what? You can see over here, from here to here, it is one pitch. Presented as P by 4. See, nearly it is 4 times. From here to here, 1. From here to here, half of it. From here to here is another one. From here to here, another one. So 1 by 4th of the pitch is the DF value. That is the meaning. A quarter value of pitch is DF. So that's why here it is represented as P by 4. The value of P by DF is P by 4 into cot theta by 2. All of you understood now? Till this, no confusion. Then again, FG, another representation. FG. See here now, the main image, FG, it can be written in the form of AF minus AG. Fg can be written in form of AF minus AG. So you're going to get this distance, Fg distance. Now for this, again they're going to do the substitution. You can see here, I've taken this Fg is equal to AF minus AG. I've taken this image, main image again in this slide also. Fg is equal to AF minus AG. Now the substitution, AF, this AF value, this P by 4 cot theta by 2. How you obtained is, in the previous one, AF is P by 4 cot theta by 2. All of you can see this cursor, right? AF is P by 4 cot theta by 2. This, it is been represented in this AF value. And again, AG means this equation, what you obtained, AG, d by 2 into cosecant theta by 2 minus 1. That is being represented here. That is being substituted for this. I hope all of you are understanding, right? So now, but E minus T is equal to 2 times the Fg. E means effective diameter. T means the dimension under the wires. So E minus T is equal to 2 times the Fg. This is another equation you can write now. E, you can observe the main image. This is E minus T, this distance, right? 2 times, it is Fg only. 2 times, why it is 2 times means, in the main image it is showing only on one side. But if you take the other side also, you can see the cursor, this side, this also Fg will be there on this side also. That's why it is 2 times the Fg. You can write this equation also, E minus 2 in terms of 2 times the Fg. See here, considering Fg on either side of the thread. Here in the main image it is showing only on one side. If you take two sides also, that's why 2 times Fg. So finally the equation, the value of C will be P by 2, because here 2 times this Fg, it is being multiplied, right? For this equation, Fg is equal to P by 4 cot theta by 2 minus T by 2 cosecant theta by 2 minus 1. This is being multiplied by 2. If it is being multiplied, this will get cancelled. So finally you're going to get P by 2 cot theta by 2 minus D cosecant theta by 2 minus 1. So this is the final equation. Till this equation, you have to do the derivation or small the equation what you have to get from the main image. This is important. 2-wire method. One more is the 3-wire method. Both usually will want to ask in the VTU question paper, right? So if you take an example, it has been shown for Whitworth thread. Whitworth thread means, like I told, the angle will be 55 degree. Angle means the thread angle from one flank to another flank. It is 55 degree. If you substitute this 55 degree in here, the value will become, this equation will become C is equal to 0.9605 pitch minus 1.1657 D. The small p represent pitch of the thread, right? Small p, pitch of the thread. Small d represent diameter of this wire which is being selected. So using this equation, if it is Whitworth thread, you can able to calculate the value of C. You can substitute into that equation E is equal to T plus C to get the effective value. This equation is equal to T plus C. Because T value anyhow you can able to obtain M minus 2D. You can see here represented, right? Finally you can get the value of E. Similarly, if it is a metric thread, right? If it is a metric thread, here, right, 60 degree, it will become, if 60 degree if you substitute in here in this equation, it will become this 0.866 P minus D. P is pitch, right? D means the diameter. So finally you're going to get the value of C. That value of C, if you substitute into this equation, you're going to get the E value, effective diameter of the screw thread or pitch diameter of the screw thread by using two wire method.